Algebra 2, Lesson 8.8, we're going to be solving logarithmic equations today. And notice what we have at the top here for note number 1. Very, very, very importantly, you can't take the log of 0 or of a negative number. More to the point, inside of the log, you cannot have negative numbers or a 0. Answers, however, could be negative. We're going to see that sometimes just because you have an answer that is a negative value, it might actually still be okay. Why? Look, the negative 1, if x was equal to negative 1, it really is the answer. What we're going to do is look inside of the log as a little bit of a check. And when we're doing our little check here, if x were to equal negative 1, this x plus 9, the negative 1 plus 9, if you plug that in, is just going to be an 8. That's going to be okay. So answers for x can be positive, negative. They can be fractions or decimal. What definitely must happen, though, is the inside has to be positive when you plug that x value in. So with no further ado, I want us to get into some of these problems. We're always going to do a check because some of these problems will not have solutions, and we have to be very careful about that. Guys, for example 1, logs look new to us. We're going to go ahead and make a log circle. We can write this as 3 raised to the second power. Set that equal to 2x minus 6. 3 to the second is 9. And then we go ahead and we're going to solve. I'll add a 6 to both sides. And you can see pretty quickly 9 plus 6 is 15. And when you divide by 2, you'd get 15 over 2. But the question is, does this work? We might have to throw this out. As we're going to do ourselves a little checking right here, again, our focus is primarily on the inside of a log. And that's right in here. So if we were to, take a look, does x equal 15 over 2 get us a positive number when we plug it in? Well, you don't even need a calculator to check this. You're more than welcome to have it. But look, the 2's cancel, and you'd have 15 minus 6, which is a 9. That's greater than 0. We're going to be good to go. Now, of course, you could go further. You could actually show that, this really does work, and you could show that, as you would get your final answer here of a 9, you could show that the log circle would work, 3 to the second, would equal a 9, and that checks, and that's great. Honestly, for our check, though, it's going to speed us up if we just check if the inside, once we plug in our x value, is positive. Take a look here. We're going to do a log circle. 2 to the second is equal to negative 5x plus 9. 2 to the second is a 4. And right now, I'm just going to recopy this problem. Tell you what, I'm going to subtract a 9. And 4 minus 9 is negative 5. And as I divide by a negative 5 here, you can see x will equal 1. So the check that we really have to be concerned with is really just, is this inside part going to be positive? So I'm going to check what happens when I plug in x equals 1 into this. So that's negative 5 times a 1 here. Negative 5 times 1 is a negative 5. And negative 5 plus 9, I started to just get that final answer in my head. You can see it's going to actually be a 4. That's positive. We are good to go. If we would have gotten something negative when we'd plug it in, we'd have to say no solution. That's the other side of it. If the inside of the log, when you plug in an x value, fails, then you're in trouble. Well, for example 3, we're getting into some multi-step equations. When you are subtracting two logs, you might remember that we had the log base b of m minus the log base b of n, that property. A subtraction of logs with the same base could be condensed and written as one single log. And that's what we're going to do here. We have that subtraction, and we can write this as a division, a fraction if you would, and we can say ln of x plus 1 all over 3 is equal to 4. Well, as we progress here, you can see we're going to need to do a log circle. In fact, ln is really, like we were saying, the log base e. And now we can do a log circle. With our log circle, we will get e to the 4th equals this fraction of x plus 1 all over 3. So on the left-hand side, we really have a fraction also. We have e to the 4th over 1. And I bring that up because now we can cross multiply. 1 times x plus 1, of course, is just going to get you x plus 1. And 3 times e to the 4th is just going to be 3e to the 4th. And e to the 4th we could actually work out on our calculator. We will in just a moment. Tell you what, I'm going to minus a 1 from both sides. These are not like terms, and right now you can see this is really what we're going to have for a final answer, but we'll have to go to a decimal. So typing this in on your calculator, you type in 3. Now the e, if you go where the 4 is and go on a diagonal here, there's the ln button, but right above that is e to a power. So we'll go second that, and we'll get e to the 4th, move that down, then we'll say minus 1. And if we were going to the nearest thousandth, that's the third decimal place, that's 162 plus 794. 162.794. Now, if there is an answer, that's going to be the answer here, but we really need to do a check. And guys, the check is actually going to be pretty easy. Go back to the original, which is natural log of x plus 1 minus natural log of 3. And you see what we're going to do is take a look at what's happening with x plus 1 if x was equal to 162.794. And if we were to plug that in, of course, we know we'd get something positive. So it checks. It's going to be good. The only way it doesn't check, the only way we're going to get into trouble is if that inside of the log becomes negative. So let's take a look at example 4 here on the back. And maybe the world of difference here, the world of difference that you're going to see is that you actually have multiple logs. You've got a log base 2 of x plus 6. You've got a log base 2 of x plus 3. Guys, your goal is to get your logs together alone on one side. Move your logs together. I'm going to subtract a log base 2 of x plus 3 right here. That's going to cancel out. And that's going to leave us with log base 2 of x plus 6 minus log base 2 of x plus 3. And then on the right side, we've got our 2. Now the minus here, you might remember, is going to turn into a fraction. This subtraction becomes the log base 2 of x plus 6 all over x plus 3. And then, once you have that, you can do your log circle. So we'll say 2 to the 2 equals the inside part, x plus 6 over x plus 3. And 2 to the 2, of course, is a 4. So I'm going to rewrite that just as so. So we have got x plus 6 over x plus 3 equals a 4. We could make that 4 over 1. And here we go, we're going to cross multiply. 1 times x plus 6 is an x plus 6. Here we're going to have 4 times x plus 3. And guys, we're going to have to distribute. We'll get 4x plus a 12. And I'm going to minus an x from both sides. And 4x minus x is 3x. And then I'm going to minus a 12 from both sides. And 6 minus 12 is negative 6. And when you divide by a 3, you'll get x equals negative 2. Now, if there's an answer, it's negative 2, we've got to be very careful. We have 2 logs that we're going to have to check. So I'm going to write the check over here. And we know that we solved to get x equals negative 2, but I've got to take a look at x plus 6, and I've got to take a look at x plus 3. And when you plug negative 2 in for x, negative 2 plus 6 is equal to a 4, which is greater than 0. Negative 2 comes in here. Negative 2 plus 3 is a 1, which is also greater than 0. This checks. If even one of them would have failed, then sadly we would have to say there's no solution. We have one last problem remaining, and it's actually going to take a little bit of work to do that. So I'm going to end the video here and pick up with part 2 for example 4.